Exponential equations is where the x that you're solving for is in the exponent. The first two examples were logarithmic equations because the x that you're solving for was inside the logarithm. These were the ones that we did together in groups yesterday. So you've already seen the strategy, and we're going to look at it again. And what I'm going to do for each of these three questions is sort of show you what is the main strategy for solving logarithms. Sometimes there are slightly different techniques that work great, but what we're going to do right now is practice the main strategy for solving an exponential equation. Okay? And this is, wow. This is the main strategy if you have a calculator. If you got an exponential equation on the non-calculator part, that was like your first take-home quiz. That's where you use your powers chart and get the bases of the thing. That's still going to be a main strategy on a non-calculator part of your test. Okay? But if, for example, in the first one, 12 is not on your powers chart, it is not a power of 4, we're going to need a calculator. This is the technique that we're going to use for solving exponential equations. And you're going to use logs. You're going to take the log of both sides, and the reason we use logs is because our log laws have a way to move an exponent out of the exponent spot. You have a log law that says, I can bring this exponent out in front. If I do that, I now can use my algebra skills to get x by itself. How do I get x by itself? Well, I can divide both sides by log of 4, and that would get x by itself. I can go to my calculator, I can type in log of 12 divided by log of 4, and get 1.792. Usually you'll be asked around to 3 decimal places. And your calculator also has a way to check if you're right, which is really nice in these questions. If you have a graphing calculator, there's a store button. You can store it as any letter. I like to just choose X because it's easiest to hit and type. Once it's stored as X, you can type in the original question, which was 4 to the X, and see, does it equal 12? If it does, you know that you've got it right, which is really nice. And when solving an exponential equation, I took the log of both sides, and you're allowed to take any log of any base. Usually, we like to take the common base of 10, because it's easy to write log, and then you don't have to write a number. If you wanted to, you could take log of 7,132 of both sides. But then you'd have to write 7,132 every single time, and that would be annoying. Right? As you get into higher mathematics, they like to use natural log more than log. And that's actually, like, if you think about it, natural log is only 2 letters. Log is 3 letters. You could like save yourself about maybe 58 milliseconds. All those letters are not right. But in your head, you have to say natural log instead of log, which takes longer to say. I don't know. It's a toss-up. But generally in grade 12, students like to take the log of both sides. So that's part A. Now, you're going to have exponential equations take the log of both sides as your main strategy. You're going to have that in your head. However, I'm going to tell you that sometimes you can do some simplification first that will make your life easier. If possible, and the second example is a great example of that, if possible, you will want to try to get your power by itself. In this case, can I move that 3 to the other side? Yes. What's the opposite of multiplying by 3? Dividing by 3. And if I divide both sides by 3, I will get 12 equals 2 to the x plus 1, and I will have succeeded in getting this power by itself. This is going to save you some time and make you work a little bit less. I'm going to, once we do it this way, which is the better way, afterwards, I'm going to do it as if, oh, I forgot to check that. What does it mean if I did take the log of both sides too quickly? It still works, but what does it look like? Okay? So first of all, we simplified this. We got our power by itself. It's an exponential equation. 12 is not on your powers chart. It is a calculator question. So we're going to take the log of both sides and have log of 12 equals log of 2 to the x plus 1, which your log law would allow you to bring that x plus 1 out in front. And since it's more than one thing, we have to put it in brackets. Because this log 2 is going to distribute and multiply both of those. Once I distribute that log 2, I'm going to get log of 12 equals x log 2 plus log 2. I want to solve for x, so I'll move everything without an x over to the other side. And then I can get x by itself. By dividing by log of 2. Once again, I'll go to my calculator. I'm going to get this answer to 3 decimal places. Log of 12 minus log of 2 divided by log of 2. Push enter, 2.585. And again, I'm going to hit the store button and store it as x and double check. Does it work? My original question. Yes, question.
Can I also just divide by log 2 in the log 12 equals x plus 1 times log 2?
And then subtract 1 on both sides? Yes. Yeah. So I've stored this as x. My original question had 3 times 2 to the x plus 1. And if I've done everything right, this should equal 36. And it does. So we have solved this. Perfect. Again, very nice that we can check. Now I mentioned in B, what would happen if you get, and this is going to happen, not what if, but this is going to happen to most of you. You're going to see the x in the exponent, and your brain is going to jump right away to, I have to use logs, and you're going to take the log right away. This is not wrong. It just has the potential for a common mistake. And I noticed even when we worked on the whiteboards or were working in groups yesterday, some of you made this mistake. The mistake is that you are overeager to want to bring this x plus 1 out in front. Your log law, I'll write it here in blue, on your formula sheet says this, that you are allowed to bring this n out in front if you have log b of m to the n. And the thing to notice is that n is the exponent to the entire thing inside the logarithm. That's an important thing to notice in this formula. Right now, I hope that you can see here on the left that the x plus 1 is an exponent only to the 2. It is not an exponent to the 3. And since it's an exponent only to the 2 and not an exponent to the 3, you are not allowed to use this log law yet. This log law only works if it is an exponent to the entire thing. So, if you did take the log early like this, it is not wrong, but you would have to first use the log law for multiplication. And say, if you're multiplying, that's the same as adding, and now this x plus 1 would be able to come out in front. And if I wanted to bring all of the things that have logs with numbers to one side, I have the log of 36. Can you see I'd have to subtract the log 3? And there would be a log 2. I'd also have to subtract that. Would equal x log 2. And finally, to get x by itself. And if you type this into your calculator, I guarantee you, you will get exactly the same answer as we did over here. And I want to point out, I'm going to zoom out here so we can see everything. We've done a lot of work on this page. I want to point out that in the second method, you end up with log 36 minus log 3. And in the first one, you just had log 12. What's your log law for subtracting? You could combine it, right, to be dividing. And if you combined it to be dividing, you would get 36 divided by 3, which would give you the 12. The same thing. What did we do that made our life easier is we divided by 3 right away. It made our life a little bit easier solving the logarithm. Okay. It also meant you had to write a little bit less while solving, which is nice. So if you can get your power by itself, that's usually a good strategy when solving. Doesn't always work, but it is a good strategy when solving. Okay, we've got one more on here. And actually I'm going to do an extra one with you as well, so we're going to do 2 more examples of ones that are a little bit more complicated, where you have x's on both sides. So again, it's an exponential equation. They're not on the same powers chart, so you're going to have to use logarithms. We take the log of both sides. And since this x plus 1 is the power to the whole thing, it can come on in front, and same thing with the x, it can come on in front. And we would get x plus 1 in brackets. Log 3 equals x log 6. Log of 3 is a number, so you can distribute it. And the interesting thing about where this question is right now is you have done this exact same question in grade 9 and found it extremely easy, except the only difference in grade 9 is your numbers were easier. Okay? So, for example, I'm going to change the numbers. Instead of log 3, I'm just going to write 3 instead of log 3, and instead of 6, I'm x. Instead of log 6, I'm just going to write 6. Those are easier numbers. You're used to numbers like 3 and 6, right? You're not used to log 6 as a number, right? You're never downstairs and your parents say, supper time, and you say, I'll be there in log 15 minutes. Right? You should, maybe. Maybe you should get some logarithms into that conversation, right? And then that'll take them at least 15 minutes to figure it out. And then you've got extra time. I don't know. So, we're not used to these numbers. These numbers are easy. If you had to do this in grade 9, you'd be like, yeah, that's easy. I combine my like terms. I'm going to move my 3x over to the other side by subtracting 3x on both sides. And you would get 3 equals. And since it's so easy, it would be 3x. Okay? Because the mental math is easy. We're going to do the same thing here. We have like terms with x's. We're going to move them to the same side by subtracting x log 3 on both sides, but the problem is we can't do the mental math. Okay? What mental math did you do here? You did 6 minus 3. It might have been so easy, you was like, I don't even know what I did, I just got it right. It's just like that easy, right? But let's say you didn't have the ability to subtract. You just lost it. And you had to do 6 minus 3. And you're like, no, I'm not going to do, I'm just going to leave it for later. I'm just going to leave 6 minus 3 for later. I'm going to work that mental math out when I build up my energy again. Could you write it like this? Yes. What are you basically doing? You're basically factoring out the x. And that's what we're going to do with our logarithms when they get more complicated here. You have an x on both sides. I don't know what log 6 minus log 3 is nice in my head as a number. I'm just going to leave it as log 6 minus log 3. I'm going to factor that x out. And now I can get x by itself by dividing. And of course, it would sure be nice if this worked. So I'm going to take out my calculator. I'm going to type in log of 3 divided by log of 6 minus log of 3. 1.585, 3 decimal places. And the big check to see if it works. So I can store this as x. My original question, now I had x on both sides, so I can check, well, on one side I had 3 to the x plus 1. On the other side, I had 6 to the x. Now I would need both sides to be the same thing for them to be equal. And when I push enter on 6 to the x, I have 17.11 both times. So it works. So we're going to do one more example together. The most complicated ones are where, so I'll call this D, you have x's on both sides, but you also might have extra numbers, like this 4 is multiplied. So we are going to have to use a few more log laws for this. Obviously, you can't get the powers the same. This is a calculator question, so you would take the log of both sides. Can you see on this side, you're allowed to use this log law? But on the right side, you would not be allowed to use that log law because that exponent of x plus 3 is only to the 2 and not to the 4. So I can bring out the 2x plus 1 here. But here I would first have to do the log law that says adding, and then I would be able to bring that exponent out in front. I've got 2x log 3 plus log 3 equals log 4 plus x plus 3 times log 2. We've got some expressions with x's, some without. What we're going to do is we're going to move all of our expressions with x's. So I'm going to underline those in green. There would be a 2x log 3 here, and if you distributed this to that x, can you see there would be an x log 2 on the left-hand side? I'm going to move all of those to the one side, so I'm going to have 2x log 3, but now I'm going to subtract the x log 2, and I'm going to put those ones on the left side. And I'm going to put all of the terms without x's. I have a log 3, a log 4, and when I distribute this, a 3 log 2, those will all be terms without x's. I'm going to put those all on the right-hand side, so I keep the log 4 there, I'm going to keep the 3 log 2 on this side, and I'm going to subtract the log 3 on the other side. At this moment, you have two things with x's in them. You can factor that x out. And I want you to quickly look at, if I take an x out of 2x log 3, quickly in your head, get an idea of what you would get. Okay? Did you get 2 log 3? Okay? Most people will. However, there is a common mistake that sometimes happens here, that people think when you take an x out of 2x, you're left with 1x. Can you see that you're subtracting instead of dividing? It's a very common mistake and easy to do. But I want to point it out right now, because if you're like, oh, I think I might do that sometimes. Okay? Factoring out the x is dividing. It's not subtracting. So you're just left with the 2 to log 3, and here you're left with log 2. This side is the same. At this moment, if we had chosen natural log, think of all the letters we would have saved. And now you can get x by itself. And we can type this into our calculator to get an answer. So, go to my calculator. I like to use my fraction buttons, especially when you have lots of things. Log of 4 plus 3 log 2 minus log 3 divided by 2 log 3 minus log 2. Push enter, 1.574. And we're going to double check to see if this works. So again, I'm going to store it as x. My initial question on the left-hand side was 3 to the power of 2x plus 1, 95.26. On the right-hand side, I have 4 times 2 to the exponent of x plus 3. And if it's the same answer, then we know that we've done it correctly. Yes. Now these questions we've done today, solving logarithmic equations and solving exponential equations, have been what everything we've done up to this moment has been building towards solving these. So on your test, like 40% of your test, 20 marks out of the 50 at least, are solving what we did today. Because it uses all of your laws and applies them to solving equations. Okay, so questions for practice on this one are 7, 8, 10, and 12. And also something about logarithms. And just zoom to the entire page here. They are very predictable. Solving exponential equations requires that you use your log laws to get x by itself. They're the same every single time, but we need to make sure that we're really good at our log laws. Solving log equations are the same every single time. You have to combine as a single logarithm. Change to exponential form, and then check your answers for extraneous roots. But just because they're the same every time doesn't mean that you'll be able to do them if you don't practice. You do need to practice to get into the groove. And I suggest when you're at home, every once in a while, like, doesn't it kind of look impressive? Like, do your math homework, leave your book out on the kitchen table. Let your parents look at this, scares them a little bit, if they haven't done it for a very long time, if ever sometimes. So it's sort of like, just scare them. Leave your math out. It looks, it's not that bad, but it looks impressive, right? Especially even if you have someone in grade 11 in your house, you're like, oh yeah, that's scary looking. They haven't done grade 12 yet, they don't know what logs are.